Alright, in this video we're going to be going over how to name acids and name bases. So, acids are going to be in aqueous solutions characterized by a hydrogen at the beginning of the compound. So, our acids are going to be really easy to identify because they're going to have a hydrogen out front. So, if it has a hydrogen out front, we're able to classify it as an acid. So, for example, our hydrochloric acid will be our HCl. Nitric acid will be our HNO3. Sulfuric acid, our H2SO4. So again, for all these acids, we have a hydrogen out front. Now, we do have three different ways that we're able to name acids. Our first one is going to be if the acid does not have oxygen in it. So this is if it does not have oxygen. What we're going to do is that we're going to find the root of the element name. We're going to add the prefix hydro to it. Our third step is that we're going to add the suffix ic at the end, and then add the word acid to make it an acid. So our HCl, for example, so our Cl will be our chlorine. So we are going to have our chlorine, so this is going to be and what we're going to do is that we're adding that prefix hydro to it, but what we're also doing is that we're changing the last little bit to IC. So this INE is going to change to IC, so we get our chloric. So hydrochloric, and then adding that word acid at the end. So that is going to be how we name an acid that does not have oxygen in it. Now, if the acid does have oxygen in it, we have kind of two different ways that we're able to do it. Now, if it does have oxygen in it, we're going to look on the back of our periodic table and find our polyatomic list. So if it does have oxygen, it is going to be a polyatomic. So if the polyatomic ends with ATE, we're going to change it to IC. So it'll be 8 to ic. If the polyatomic ends with ITE, we're going to change it to OUS. So this is going to be ite to us. And then we're going to add the word acid. So looking at our HNO3. So this is going to be our nitric acid. But our our NO3 first is going to be our nitrate. So this is going to be our 8 to ic. So we're going to get nitric. And then looking at our ClO2, this is going to be our chlorite. And we're going to change that ITE at the end to our OUS. So we're going to get our chlorous acid. Now, kind of a way and everything that we're able to remember 8 to ic, ite to us, is that I ate it and I got sick, so 8 to ic. And then ite to us can be I took a bite and it was delicious. So ite to us. All right, so looking at our H3PO4. So our PO4 right here, all right? So first thing we need to look at is, does it have oxygen in it? In this case, it does have oxygen. So we're going to be looking on our polyatomic list. So we'll find our PO4 on our polyatomic list, which is going to be our phosphate. So we get our phosphate. Now, we do have that ATE, so that is going to change to our IC. Now, because of some spelling and just making sure that it sounds correct, so instead of it being phosphic, we're going to change it just to phosphoric. Phosphoric just sounds a little bit better, but if you were to write our phosphic, that would also be okay, especially for this course. Now, looking at our H2SE, All right, so first thing, it does not have oxygen. So no oxygen, we are going to use the prefix hydro. So no oxygen, we're going to use hydro. Now, we're going to also have our Se, which is going to be our selenium. So our selenium. And we're going to change that last little bit to Ic. So what we're going to change this to is going to be our selenic. So it'll be our hydroselenic. And then we're going to add the word acid. And so this right here is going to be our name for our H2SE, hydroselenic acid. All right, let's go ahead and take a look at our next one. So this will be our H2CO3. All right, so our CO3, it does have oxygen in it. So we're going to take a look at the back of the periodic table. This polyatomic is going to be our carbonate. So we have our carbonate. Now with that ATE, we're going to change it to IC. So we're going to end up with carbonic. And then finish it off with acid. So carbonic acid. And this will be our name for our H2CO3. All right, taking a look at our HNO3, we do have oxygen, so we're going to look on the back of our periodic table. We are going to find our NO3, and our NO3 is going to be our nitrate. Now, our ATE, we're going to change this to our IC, so we're going to end up with nitric. And then we're just going to end with acid. So, nitric acid. And that will be our formula for our HNO3. All right, now let's go ahead and take a look at base and how to name our bases. Now, bases are going to be ionic compounds that are characterized by a hydroxide or an OH at the end of the compound. So it is always going to be a metal plus our hydroxide. So our sodium hydroxide will be our sodium plus our OH. Potassium hydroxide, potassium plus our OH. So this is going to be a really good way on how we name our bases. So we're going to name the metal ion. We're going to follow it up with the word hydroxide. If there is a transition metal, so remembering that our D block in that middle of the periodic table, those are going to be our transition metals, we're going to place a Roman numeral in between the metal and the hydroxide. So the example and everything that we have is going to be our BaOH2, with our Ba being our barium and our OH being our hydroxide. So barium hydroxide. All right, let's go ahead and take a look at these four. All right, first thing we have our NaOH. So looking on the periodic table, our Na is going to be our sodium. And then our OH is going to be our hydroxide. So we're going to get sodium hydroxide. And that is going to be how we name our bases. All right, let's go ahead and take a look at our AlOH3. So our Al is going to be our aluminum. Our OH being our hydroxide. So we end up with aluminum hydroxide. All right, our FeOH3. All right, our Fe is going to be our iron. Now, we may notice and everything that iron is a transition metal. So because it is a transition metal, we have to look at our charges. So what we're going to do is that we're going to uncross our subscripts. So what we end up with, this is going to be our Fe plus 3 OH minus 1. So this plus 3 right here, this is going to be our Roman numeral that we want to place. So it'll be our iron 3 hydroxide. Now again, the reason that we did that was because our Fe is a transition metal. So it's a transition metal, so it has to have a Roman numeral. All right, let's go ahead and take a look at our CaOH2. So our Ca being our calcium, and then our OH being our hydroxide. So calcium hydroxide. And that is going to be how we go from our formula to our name with bases. All right, now going from our acid and base formulas, so we're going to find the unknown element or polyatomic. For an acid, we always have a hydrogen out front, and we're going to make sure in everything that acid has an individual element or a polyatomic. So we need to make sure if it has oxygen in it or not. Our bases will always have a hydroxide at the end, so that will be our OH. We're then going to determine the charge of the unknown element. And then from the charges on the periodic table or the polyatomic ion list, or from the Roman numeral, we're going to cross, drop, and reduce those charges. So let's go ahead and take a look at a few examples. All right, we are going to have our hydrochloric acid. All right, so because it is an acid, we know we're going to have our hydrogen out front with a +1 charge. Now, hydro means no oxygen, so we do not have oxygen in this, so we're just looking at our periodic table. Our chloric sounds a lot like our chlorine, so our chlorine will be our Cl. And if we look on our periodic table, our chlorine does have a -1 charge, and so what we're going to do is go ahead and cross these. And what we end up with is going to be our HCl. So hydrochloric acid, our HCl. All right, let's go ahead and take a look at our hydrophosphoric acid. All right, it is an acid, so I do have my hydrogen out front with a +1 charge. Hydro, no oxygen. So this compound does not have oxygen in it because of that prefix of hydro. Phosphoric sounds a lot like our phosphorus, which is our P. Now looking on the periodic table, our phosphorus does have a charge of -3. So we're going to go ahead and cross these down. And what I should end up with is going to be my H3P. And that will be my hydrophosphoric acid. All right, taking a look at our hydrosulfuric acid. So, acid, we have our hydrogen out front. Hydro, no oxygen. So our sulfuric sounds a lot like our sulfur. So our sulfur being Rs, it has a -2 charge. We're going to go ahead and cross these down. Whenever we do that, we should get our H2S as our formula. All right, let's go ahead and take a look at nitrous acid. So it is an acid, so I do have hydrogen out front. But looking at this, I do not have the prefix hydro, so there is no hydro, which means I'm going to be dealing with a polyatomic. Now, because it is a polyatomic, we do need to make sure that we do get our correct word for it. So our OUS, if you kind of remember what we normally change this to, is going to be our ITE. So this was originally our nitrite, but our ite to us, our ate to ic. So ite to OUS. So this is going to be our nitrite. Looking on our polyatomic list, our nitrite is going to be our NO2. And it has a -1 charge. We're going to go ahead and cross those down. And what I should end up with is going to be my HNO2. And that is going to be my nitrous acid. All right, taking a look at potassium hydroxide. All right, our potassium is our K with a +1 charge. Our hydroxide is our OH, and our hydroxide always has a -1 charge with it. And we're going to cross these. And so what we should end up with is our KOH. All right, let's take a look at our nickel 2 hydroxide. All right, our nickel is our Ni. It has a charge of +2 given to us by the Roman numeral. So our Roman numeral is 2, so that means that we are going to have a charge of +2. Our hydroxide being our OH, -1 charge. We're going to go ahead and cross these down. So we're going to end up with our Ni parentheses OH close parentheses 2. So just remember, whenever we cross down something onto a polyatomic, we are going to have to put that polyatomic into parentheses and put that number on the outside. All right, our next one is our boron hydroxide. So our boron is going to be our B. Looking on our periodic table, it has a charge of +3. Our hydroxide being our OH, charge of -1. We're going to go ahead, we are going to cross these down. So our 3 will go on the outside of the OH. And putting this all together, we are going to get our B parentheses OH close parentheses 3. So again, just making sure that 3 goes on the outside of the parentheses. All right, taking a look at our next one, our chromic acid. So this being an acid, we know we're going to have hydrogen out front. Our chromic, so our IC and everything was normally our ATE. So this is going to be our chromate. So looking at this, we'll find our chromate and everything on our polyatomic list. Our chromate has the formula of our CrO4 with a -2 charge. We're going to go ahead and cross these down. And we're going to end up with our H2CrO4. And that is going to be our chromic acid. All right, taking a look at our strontium hydroxide. All right, our strontium being our Sr, it has a charge of +2. Our hydroxide being our OH has a charge of -1. We're going to go ahead and cross these. So this will be our Sr parentheses OH2, and that will be our strontium hydroxide. All right, so that is going to be how we go over acid-base naming. So that is going to be going from our name to our formula, and from our formula to our name.